Okay, good morning everyone. My name is Yann Bouvier and I work here in the Centro de Electrónica Industrial in this very school. And I'm going to talk about my thesis, which is, the title is a solution for high power electronic converters for aircraft applications. So this thesis is related with the topic of the more electrical aircraft, which is a tendency in modern aircraft to substitute mechanical, hydraulic and pneumatic systems by their electrical and electronic equivalent, which in principle are more efficient and less bulky, and they should lead to an increased efficiency of the airplane. The problem with this is that the electric consumption of the airplane then is going to increase, so we need new solutions for the converters. Of course, because it's avionics, the design has to be reliant on reliability, safety, and of course, as I said, it needs to be optimized. And because we don't want the aircraft to fail when it's up there, okay? So the main system of this thesis is going to be the rectifier of the aircraft, which deliver all of the power to the loads. Because the power comes from the turbine, which is a rotating element, the electrical power is delivered in the form of alternating current. So because the loads are in the current standard for avionics, 28 volts of DC current, we need to rectify and to adapt the voltage. For that, usually we have a first stage, which is the AC-DC rectifier, where we rectify the current to the direct current, and then we have a DC-DC converter where we can have the exact value of the voltage that we need. And it's in this DC-DC converter that my thesis is about. And in this converter, we can put the isolation, which is a transformer. But transformers don't work at the DC current. So we need to change again to AC power. And you can say that this is stupid because we already had AC power. But with this change, what we can do is to increase the frequency. And with increased frequency, we will have a reduced volume of the transformers and all of the magnetic components. So this is a transformer at 400 Hertz, and this is a transformer at 100K, and it will be as small as a soda can. Okay, with this increase of frequency, what we are going to have is another problem, that is increased losses in the switching components. Because in the traditional trapezoidal modulation of the current, we're going to have 6 switchings with current, with a non-zero current, and at higher frequency, it will lead to higher losses. With triangular, we can reduce only to 2 hard switchings per cycle, and the losses are going to be moderate. But the highest efficiency will be achieved with a resonant current modulation, in which we can switch almost at zero current, and therefore at high frequency the losses will be significantly reduced. So finally, we developed a prototype in collaboration with Indra and Airbus companies, and as you can see here, the resonant shape of the current that I explained before. And also you can see here a picture of the prototype, where you can see the 2 transformers that, may I remind, they are as big as a soda can. The final efficiency was 95%, which is at 10 kilowatt is quite high. And it met with all the requirements of, that the companies were asking for. So thank you very much, and wait.